got going on.
She be watching this?
Yeah. So this right here, this is module lesson 18, module 4, right, since I said module. So this is lesson 18 exit ticket. It's on page 341. So let's go ahead and first talk about the different parts and what we got going on here. So first of all, what do we call this shape? It is a pentagon. What part of it is a pentagon? The bases are pentagons. So we got a pentagon right here. That's a base. And we got a pentagon right here. So those are our two bases. What do we call all the stuff that goes all the way around the bases? So those are our lateral faces. Alright, so that takes care of the different parts that we need to know. We're going to be talking about bases, we're going to talk about lateral faces, including in today's lesson where we're going to be talking about cylinders. So the instructions on this thing says to find the surface area of the right rectangular pentagonal prism. The line segment labeled 4 meters begins at the center of the pentagon and ends at one side of the pentagon. So, first off, this would be really easy because the first thing that we need to do is we need to find the area of one base. And it would be really easy if this was a rectangular prism, right? It'd be super easy because all we had to do, we know the formula to find a rectangle, we would just do length time width and find that area of that base, right? Yeah. Or if this was a triangle, we would do base time height and divided by 2. But do you know the formula to find the area of a pentagon?
No.
No, there is none. So what we need to do is we need to look at this picture that they have for us here and deconstruct this particular problem. So if you look at the center, and if we draw a line here and draw a line here, we just created a triangle, and we actually have 5 identical triangles. So what we're going to do to find the area of the base down there is we're going to do all 5 of those triangles, and we're going to multiply it times the area of one of them. So that's base time height divided by 2. So we're going to do 5 times the base of this thing is 5.8 times the height, which is 4, and we're going to divide it by 2. And when we start the next lesson, you can go ahead and grab a calculator. For now, I'm going to go ahead and do the math for you. So it's 5 times 5.8 times 4 divided by 2 is 11.6. So that's one of those triangles, but we got 5 of them, so we're going to do 11.6 times 5. So that means that the area of that base down there at the bottom is 58. 58 meters squared. Okay? But how many bases do we have again?
2.
We got 2. So that means I have to find the area of both bases, because we got the top and the bottom. So the area of both bases. So do I have to do some type of formula for this to find the area of both bases? No, we done found one. So if I got 2 of them, I'm just going to do 2 times 58. So 2 times 58 is going to be 116. And that's one of the numbers that we're going to need to be able to find the surface area. And the surface area is all the parts of this thing that we can touch, right? So we can touch the top, we can touch the bottom, and then we can touch everything on the outside of the sides, right? Of the lateral faces. So after that, we then found the area of both bases. The other thing that we need to add to that is the area of the lateral faces, of all the lateral faces. And to find the area of the lateral faces, we're going to take the height, and we're going to multiply the height times the perimeter of the base. So the height of this thing is 6.3. And then to do the perimeter, we need to add up all the sides that go around the base. And they're all identical, so they're all 5.8. So you could do 5.8 plus 5.8 plus 5.8 plus 5.8 plus 5.8, which would be adding all the sides up. Or you can just do, hey, this is a pentagon, it's got 5 sides, and all of them are equal to 5.8. Okay? So when we do that, we're going to have 6.3 as my height, the perimeter is going to be 29. Which means the area of my lateral basis, I'm going to do 29 times 6.3, and that's going to give me 182.7. So the 116 that we have right here in the square, that is the area of this thing and the area of this one at the bottom. The 182.7 is the area of all of those rectangles that hold those two pentagons together, right? So to find the area of the whole thing, the top, the bottom, and all of the sides that go around it, all we need to do is add those together. So this is going to be surface area is equal to 116, the area of both the bases, plus the area of the lateral faces. And when we add that together, we get 298.7. And they give us that as in meters, so at the end I can go ahead and put meters squared. You don't have to put it on a test, but I like to tell you to try and think about putting it, because when you're gonna get to higher maths, I don't know what they're gonna do in high school. I don't even know if Miss Trucks makes you put it on there. But some teachers, they're like, I'm gonna take a point off if you don't put what the unit is. For me, that I could care less. As long as you know how to find it, who cares if you remember to put an M squared on the back end. Okay.
Does it always have to be in square?
No, if it's inches, it's going to be IN squared, or inches squared. If it's centimeters, it's going to be centimeters squared. If it's miles, it'll be miles squared. Kilometers will be kilometers squared. If they don't even give you a measurement, it's going to be unit squared. But for area, it's always squared. For volume, it's always cubed, because for volume, you multiply in three numbers: length, width, height. Okay? Any questions on that? So that was lesson 17 and 18, really, because 17 we did the baby way, just kind of help us build up to lesson 18. So now let's take a look at lesson 19. So to do lesson 19, the first thing I would like for you to do is to
We gotta get it real.
get into groups of 3 real quick.
Oh my God.
So go ahead and get into groups of 3. If you want me to put the groups together, I'll be more than happy to. If you want to get into your groups real quick, I'll let you do that. You got 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2. I get to 0, I'm putting the groups myself, so you might want to start moving. I don't understand why you gonna wait till there's a second left to get your butt up out the seat. I was on 1 already. Groups of 3. That's a group of 4. That's 4 people right there. Groups of 3. 3 people. That's what happens when you stay sitting down in your chair and don't get up and move around. You know? So,
I'm not working with y'all.
everybody ready? Devontae, since you up real quick, can you give everybody a ruler? Why don't you go ahead and grab everybody a calculator? Dwayne, you can give everybody a pair of scissors. So, we're going to start off with, we're going to be using our calculators today. We're going to be using our rulers, and scissors is going to be just for this one activity. So I'm going to give everybody one of these. And I'll wait to start talking once everybody gets everything passed out. Alright, so everybody's got a shape that looks kind of like this, right? Alright, it looks like a jar, it looks like a Coke can, it looks like a can of peas or a can of corn or a can of soup, right? Anybody know what we call these shapes? Cylinder. Yeah, absolutely, it is a cylinder. So what I want you to know is, what I want to ask you is, how is this object similar to a right prism like we did yesterday? We had rectangular prisms, triangular prisms. We just finished messing with a pentagonal prism. How are these things like a prism? Both got 2 bases, you said? Or faces? But they are technically faces, but they call bases, right? So does this one have two bases? We got a base right here, and we got a base right here, right? Okay. Anything else that you can see that is similar? Demonte? You raised your hand. I asked the question.
Okay,
You
what
raised.
was the question?
He was like.
Anything else that this is similar to a rectangular prism? What you think, Elena? You don't got nothing? You just,
She said she got something. The lateral faces.
it got what? It's got lateral faces, right? Technically. I mean, it's got something that goes around. We know that the definition yesterday of a lateral face was that it held the bases together, right? So there's got to be a lateral face if it holds the bases together. Okay? It might be called something different, though. We'll see that in later on. Anything else? Why do you think it's called a right cylinder?
Because all the sides are equal.
All the sides are equal? So this side right here is equal to this side right here?
Because they're all the same shape.
Right prisms will be called right prisms. Let me find my prism real quick. So why was this called a rectangular right prism? Or a right rectangular prism? Why was it called a rectangle?
Because each side would be a base.
Because the bases were rectangles, right? Okay. So why was it called right?
Because it's made out of right.
Because all the lateral faces are right angles, right? Ain't this a right angle right here? Ain't this a right angle right here? So why do you think this thing is called right?
Because it had a right angle.
The right angle right here too, right? Yeah, it's not crooked like this. It's not like you done took the can of soup and threw it on the ground and the thing's all bent up, jacked up, right? It's got a right angle right here. So that's why it's called a right cylinder. All right? Now, we just talked about how is it similar. How is it different from a right prism?
All the sides are round.
Yeah. Yesterday, all of our sides were rectangles, right? You see any flat part anywhere on this thing except for the bases? No. So all of these lateral faces, what we calling them right now, they're not flat. They're not rectangles. It's around. Okay? So what we're doing in this topic is finding a surface area, right? So surface area on this rectangular prism, to find a surface area, I had to find the area of this, and the area of this, and the area of the back, and the front, and the sides, right? And add them all together. Surface area was everything that I could touch. You think it's the same thing on this?
Yeah.
Surface area is everything I can touch?
Yeah.
So what can I touch on this thing? How can we find the surface area of this?
You can touch the two bases.
I can touch the top and the bottom.
And you can touch the
So can I find the area of this?
Yeah.
What shape is that?
A circle.
A circle? Again, I'm not having no participation from this side again. What shape is this? Circle. Can you know how to find the area of a circle?
Yes.
How do you find the area of a circle?
Area is equal to pi
Pi r squared, right? Okay? So cool. We can find this. Pi r squared, pi r squared. Add them together. Okay. That takes care of the top and the bottom.
Right.
Can I touch all of this too?
Yes.
How am I going to find the area of all of this
Isn't that
if it ain't got no rectangles nowhere on it?
isn't that
The perimeter?
the
This right here is the perimeter?
No, guys, you know, like when you're trying to find a lateral, you gotta do the perimeter times the height.
Right?
So, isn't that?
That's a good idea though. Maybe that's what come up in the lesson. Because in the last class they were like, we don't know. We don't know what shape this is or what this even means. Okay? But that's what we'll be working on at the beginning of class. We're gonna figure out how, because this top and the bottom's easy, right? It's how can we figure this out? And that's what we'll be working on with your little block that you have right now and your scissors and stuff. Okay? And so you how we're gonna do that. I'm gonna pass out 2 pieces of blank paper to you. So we said that a net is a lot like a perfect gift wrap, right? We talked about yesterday, we had that little man or woman or whatever it was wrapping a gift. Okay? We don't want any overlap. So what I want you to do right now is to use your scissors, and I'm going to come around and give you a couple of pieces of tape. Use the tape if you need to. And I want you to wrap this present, wrap this cylinder. So pay very close attention to how I'm going to do it. So I'm going to tell you exactly how I'm going to do it, and I'm going to come sit down here and do mine.
So you only gave us two.
2 sheets of paper is all you need. That's what I just said. I'm gonna give you 2 sheets of paper, and I'm gonna come get you some tape in a second. Okay? So here's what I want you to do. Pay very close attention, because we had a couple of groups in the other class that didn't pay attention, and they were like, oh no, what to do? And it took them 20 minutes. I'm not spending 20 minutes on doing it. So, we need to be able to make a net, right? All the nets that we made yesterday, we started with the base. If it was a triangle, I drew a triangle, right? If it was a rectangle, I drew a rectangle. And then I went ahead and drew all my lateral faces attached to that, right? So what do you think I want to start with now? Circles, right? I don't want to measure these circles. That's going to take too much time. So I want you to take your cylinder, put it down on your paper, and trace out the circle with your pencil. Okay? Wait, listen to all my instructions first before you start doing anything. So trace out each circle. Do you think both the circles are identical?
Yes.
Okay? So I want you to trace out both circles. Then we got to be able to get all of this part too, right? So I want you to take your cylinder and lay it down like this. Okay? And then draw your little line right here, and draw your little line right here. That way we can see what's the height of your cylinder. That's the height, right? So make a line right here, make a line right here, and then on your paper, I want you to draw some lines, straight lines, right where the height was. Cut the circle out, cut both circles out, and then cut the rectangle out that you're going to have with these 2 straight lines. And then take your paper and wrap it around. And so these look kind of confused right now, so I'm going to show you what I did. This is what I did in the last class. So first things first, I cut out, I'm forgetting I want to do this on camera. I cut out both my circles. Okay? So these circles fit right on the top and right on the bottom. Okay? Then I took my paper, I had my paper down here, and I put my thing on top, and I put a tick mark right here, and I put a tick mark right here, and then I drew lines, and I cut along those lines so that I had this rectangle. And I took my rectangle, and I wrapped it around so that it's like a perfect piece of wrapping paper with no overlap, right? Because in the other class, they had some of the people that had it overlapping. But we wanted to be perfect, so right where it touched, any overlap I had, I cut. Okay? In the other class, they taped it. They taped this, and they taped the circle on top, and they taped the circle on the bottom. But then, and then they came showing me, they were like, look, we wrapped it. I said, okay, now untape it so that it all can lay flat like a net should. Okay? And that's what I want you to do real quick. Make your own net. We all got different size cylinders. So go ahead and do your cylinder. All right, here we go. So, we should have a net. Now again, my net, you can't really see it all on the document camera, but I have one really big rectangle because my shape is really big, and then 2 circles, right? Okay, so we went ahead, we put the base down on the paper, we traced it out, we made circles, right? What do you notice about both the bases, Tyrus?
What do you notice about both of these?
They both what? Equal. I don't know what equal means. Equal to what? 6? 15? What that means? They equal. Tell me something a little bit better. Okay, he don't know any word other than equal. What do you think they mean, Dwayne?
They're both the same size.
Both the same size, or they're both identical, right? Okay, yeah, that sounds better. So, both our bases are identical. They're identical what?
Circles.
Circles. They're both identical circles. So, first off, I want you to go ahead and label your bases. So this is a base, and this other one is a base. And do we know how to find the area of these bases? How do we find it? Area is equal to pi r squared. That's how to find the area of a circle. So I'm going to hit label that as well.
Who was sitting over there? Who was sitting over there?
What Santa is?
No, who was sitting over here?
I have no idea.
It's like Juliet handwriting.
Okay. All right, so we got two bases, they are identical, and the area to find both of, or the formula to find both of them is pi r squared. Now let's go ahead and take a look at the rectangle part. We took the rectangle and we were able to cover this and make it go around our cylinder, right? Okay. So my next question for you about this piece is, what do you think this side is called again? Those told me lateral faces, right? So it is a lateral face if it is on a rectangular prism, because it actually is a face. It's the face of a rectangle. But this is curved, right? So it's not actually a face. It's not called a face. It is still lateral, because lateral means you go up and down, right? So what we call this one is we call it the lateral surface.
Okay. Do we gotta split our pages into two like you do?
Not yet. That's coming. This is the one I used in the last class. So I'm just going using that. So the curved surface that joins the two bases of the cylinder together, it holds those two circles together. It's not lateral faces, it's called the lateral surface. Now, what shapes do we have on this net? Because right here we're looking at a net. So what shapes do we have?
A rectangle.
I see a rectangle. Here's my rectangle. And what? And two circles. Sure. All right. On rectangular prisms, it was a rectangular prism. We had a rectangle on the top, rectangle on the bottom, and then four rectangles, right? If it was a triangular prism, it was a triangle on the top, triangle on the bottom, and three rectangles, because the triangle got three sides. It was a pentagonal prism, pentagon on top, pentagon on bottom, and how many rectangles we had going around? Pentagon, 5, right? Pentagon has 5 sides. So in this one, we've got two bases, but those bases don't have sides, so then it's just one rectangle that we have to figure out. Okay? So, how do you, we already talked about how we can find the area of this. How do you think we're going to find the area of this? Length time width. Sure. We definitely going to do length time width. I went ahead and drew a picture, drew a line right here on mine. I don't think she's joining, but oh well. So I went ahead and drew a line on this one. What do you think this line represents? I'm sorry. What do you think this line represents?
All the sides.
All the sides?
The height.
It's the height. The height of what?
The cylinder.
The height of the cylinder? So if I take my cylinder from here to here would be the height, right? That would be that area that I told you to draw. When I told you to put the paper down, I said put a tick mark right here and a tick mark down at the bottom, and then that would be your height, right? So that's exactly what this is. I went ahead and did my height. Okay? You don't have to do that. You don't have to do the same thing because we're not going to find the area of this. But I went ahead, I just want to show you that this is the height of the cylinder. So the height of the cylinder, when we look at the rectangle, what part is that? Is that the length or is that the width? That's the length, right? I mean, it's the length or the width? It doesn't really matter, technically. I don't really care, like I've always said. It's supposed to be the width, okay? Because the width is supposed to be the small part, and the length is supposed to be the long part. So we'll just say that it's the width, because it's equal to this side, right? So this piece right here is equal to that. All right. So that's all we're doing with this, just so you can see all of the different parts. Oh, wait, I forgot something. Y'all said length time width, right? So this is the width. How do we figure out the length? Without measuring it. Because when you've got a picture like you have on number 1, can you measure it? Can you unroll that thing by yourself and measure it? No, so we gotta have a different way to measure it. Let's see how we're gonna do this. So notice on my picture right here, everybody take a look up here. We said that this was the height of my cylinder, right? Here's my height, okay? Which is also on this rectangle, the width. What we need to figure out is the length. I want to figure out how long this line is, but I got to be able to do it without measuring, because they're not going to have it in the picture where they're going to be like, oh, look, just so you know, when this thing's all wrapped around, all the way around there, that's 10 centimeters. They're not going to do that. We have to have another way to figure this out. So keep your eye on that length, that line at the top right here that we're trying to measure out, right? So I'm gonna take my cylinder and I'm gonna wrap it around. Where's my length at? Is this my length right here? That's not my length? Is that my length? This is my width. So is that my length? So my length is what goes around my base. So, yeah, what shape do we have right here? A circle. So what is the outside of a circle called? Circumference. So if I want to figure out how long my length is, the only thing I got to do is figure out what's the circumference of my base. Okay? And that's how we're going to be doing this problem today. So let's go ahead and take a look at number one. We're going to do number one together. Number 2 and 3, I'm pretty much going to let you do on your own. I'm going to tell you the other class, the ones that were paying attention, so AKA Demaya and Christine. After number 1, they were like, we good. We're going to go ahead and do all the rest of them on our own. And they did. They did 2, 3, 4, 5, and 6 all by themselves, knocked it out, came up here, told me what the answer was, and the answers were right. Okay? So, pay very close attention to number 1. Demaya was like, I usually don't like to pay attention because I don't really understand some of this stuff because it'd be hard. But this is really, really easy. And it's really, really easy only because you paid attention to this problem right here. So we got problem number 1. And in problem number 1, they want us, in part A anyway, to first measure the height and to measure the radius of one of the bases. Now, in my book, when we're doing it in centimeters too, by the way, my book's the same size as yours. The book, and I thought it was wrong because I went up here and I measured mine in centimeters, and I did like this, and I was like, hold up a second. This thing, they told me that this was 3.8. Am I anywhere close to 4? No. So then I was like, they must have had my picture shrunk down or something like that. So I grabbed Yushai's book, and I put my ruler up on Yushai's book, and it was the exact same thing. So does yours look just like mine too?
Yeah.
If we measure the radius, put your 0 on that center dot. And then if you look at it, the line ends right here, 2 tick marks past the number 2, right?
Yeah.
Okay, so let's go ahead and this is how we're going to measure it out. You got to count how many tick marks they got till you get to the 3. Now, if you're doing inches, there's 16 tick marks till you get to the number 3. But with centimeters, there's only 10. Okay? So if we think about it as being tenths, each tick mark is a tenth. This is 2, 2 and 1/10, 2 and 2/10. Okay? So in your book, you can go ahead and label that your radius is 2.2 or 2 and 2/10 centimeters. Okay, we go with the radius. Okay, let's go ahead and measure the height. And when you go from center dot up here at the top base, and then down to the center dot down here at the bottom base, you'll see that it goes 7 tick marks past 5. It's actually 2 tick marks past 5.5. So that would be 5.7 centimeters. Okay, and this would be the only one that we got to measure, by the way. This is the only one. Okay, so everybody got our numbers?
Yes.
Go with that. All right. So then part B, so part A was measuring. Now I'm going to go ahead and put this down. We're doing part B now. Part B says to draw a net. Draw a net, and of course if we're drawing a net, we need to label it. So I'm going to go ahead and instead of starting with my bases this time, because there's only one rectangle here, I'm going to go ahead and I'm going to start off with my lateral surface. Yeah, that's what it's called. Lateral surface. Now, obviously, we're not going to draw this to scale, so I do not want this to be 5.7 centimeters tall and all of that stuff. We're just drawing a model right here. So you don't even have to use a ruler if you don't want to. I'm not using no compass to draw no circles. So I'm just going to draw the best circle I can. Here's one base, and then here's another base. And basically there's my net. But now I need to go ahead and label everything that I know. So we know one number was, flip back to mine. I know that the radius, so I'm gonna put a dot in the middle right here. Put a dot in the middle right here. I'm gonna go ahead and draw my radius on that base. Draw my radius on this base. And the radius was 2.2 centimeters. So that's 2.2. This one's 2.2 because they're identical. And then I know that my height, which is the width of my rectangle, right? So right here is my height. That was 5.7 centimeters. Is everybody with me so far? Good? Okay. So that takes care of part B. Part C, they want us to find the approximate surface area. When we talked about doing something approximate with circles, what did that mean we were doing? Pi, what we do, we left pi? Or we put 3.14 for pi? Because 3.14 is the approximate value for pi, right? So they want us to use 3.14. I'm not going to use 3.14. I'm going to find the exact answer first. That's what all the rest of the questions want you to do. And then we're going to use that exact answer to then find the approximate answer. Understand that? Okay, good. So that's how we're going to do it. If you got any questions, just stop me. We'll talk about it. So this is part C. We're going to be looking to find the surface area. And you might be thinking, oh, here we go. We got some whole new steps to do. Really, we don't. Surface area is the exact same thing. I'm going to do just like we did with rectangular prisms. I'm going to find the area for one of the bases. If I got an identical base, which I do, because all my bases are identical regardless of the shape, unless it's a pyramid, I'm going to multiply it times 2, and then I'm going to find the area of the lateral surface, and then add them together. So it's really all the same thing. So what we're going to do, it's going to look exactly like yesterday's stuff with a couple of tweaks. So the first thing I'm going to do is I'm going to find the area of one base. How do we find the area of one of these bases? Do what?
Is pi r
Sniff them.
No, I said,
Oh, he said circumference.
No, circumference ain't area. Circumference is how much it is going around that. I don't want to know how much it is around. I'm not building no fence around this circle. I want to know what's on the inside. So how we find the area of a circle?
A squared.
Pi r squared. Pi r squared. Okay? So I'm going to go ahead and plug in for these variables that I got right here. But I'm not going to do 3.14 for pi yet. So I'm going to pretend like pi is just another variable. It's another x, it's another y right now. Okay? And we know how to work with those. So I'm going to leave pi alone. And I'm multiplying pi times my radius. What is my radius in this circle? 2.2. So I'm going to do 2.2 squared. So when I multiply 2.2 squared, or 2.2 squared is just like doing 2.2 times 2.2, right? So when you do that, you get 4.84. Now in algebra, am I going to leave this like this, where it's pi times 4.84? What's a better way to write that in algebra? Yeah, 4.84 pi. So that is the area of one of these bases. So now to find both of them, I'm going to times it times 2, right? So that's my next step. I'm going to do the area of both bases. And just like Ayana said, I'm going to do 2 times the area of the one base. So 2 times 4.84 pi. So when I do that, 2 times 4.84, I get 9.68. Wait, am I missing anything? The pi, yeah. Because if I'm multiplying 2 times 2x, what's 2 times 2x? 4x, right? So I can't forget the variable on this one. If I'm doing 2 times 4, That's gonna be technically 8 pi, but we got that decimal on here, so this is gonna be 9.68 pi. So that's both bases. And yesterday I put a box around that answer because that's gonna be part of our surface area. That's one of the numbers that we need to get to the final answer. So we just found the area of this thing, and we found the area of this thing. We put them together, right? So what's the only other thing I gotta find the area of? The rectangle. So I'm gonna find the area, and I'm not gonna call it. I'm not gonna say, hey, I need to find the area of my rectangle. I'm gonna say I need to find the area of my
Surface.
not surface area, lateral
Lateral
surface. Lateral surface. I heard Dom say face. Those are on when it's rectangles. Okay, so that's prisms. So we gotta find the area of my lateral surface. But which shape is my lateral surface? Bless you. It's a rectangle. So to find a rectangle, I've been doing that forever. Area is equal to length times width. So I need to figure out what my length is. What's my length on this picture? Right here. What's that number? Oh snap, we don't know. We gotta find the what? We gotta find the circumference to know that number. Okay? So right down here, I'm gonna go ahead and do circumference is equal to, God, what is circumference equal to? Pi times the diameter. So pi d, right? Okay, so circumference is equal to pi d. Again, I'm leaving pi alone. I'm gonna multiply it times the diameter. Is this the diameter? No, that's the radius. So the diameter will go all the way across. So that's this one plus another one like it. So what's 2.2 times plus 2.2? 4.4. So my diameter is going to be 4.4. Obviously, I'm not going to leave it like this. I'm going to go ahead and just write the circumference as 4.4 pi. Alright? So that means that this length right here is equal to 4.4 pi. Now, do I have my length and my width on my rectangle?
Yes.
Alright, so I'm going to go ahead back to my formula and I'm going to plug that in. My length is 4.4 pi times my height, which is 5.7. And I'm going to multiply those numbers together. 4.4 times 5.7, and that gives me 25.08 pi. 25.08 pi. Alright, so there are my two pieces. That's the two pieces that make this up. So I got my two bases. Those are 9.68 pi. I got the area of this rectangle. That's 25.08 pi. So now the only thing I got to do to find my surface area is just to put them both together, right?
Yes.
So my surface area is going to be equal to 9.68 pi plus 25.08 pi. Now some people are going to ask me, can I add those two together? Do I have like terms? Because you told me that I can only add x's and y's together, right? X's got to go with x's, y's got to go with y's. Do we have the same terms right here? Yeah, these are like terms. They both got pi, right? So we can add these together. So we're going to do 9.68 plus 25.08. And you get who? 34.76 pi. That is our exact surface area. Okay? So in the other problems that you're going to be working, this is the next problem, and then the problem after that. So it's definitely 2 and 3. This is going to be your part B. Okay? Because drawing your net is part A, doing the exact is part B, and then the next part they're going to have you find the approximate. Okay? So now we're going to go ahead and take this. This is going to be like doing part C in the next problems. Now we're going to find the approximate like they wanted us to do from the get-go. So to find the approximate, all we need to do is take that answer, 34.76 pi, and instead of pi, we're going to approximate what pi is. 34.76 times 3.14. So we go ahead and multiply those two numbers, and you get your answer, 109.14. 1464. And that was centimeters, so I'm gonna go ahead and put centimeters squared. I could have put centimeters squared up here too. So that 109.1464 centimeters squared is our approximate answer for pi. Any questions on what we did?
No.
Looks like the same steps from yesterday?
No.
Yeah? Think it's gonna be tough?
No.
No? Okay. Go ahead and work on number 2 with your partners. And then after number 2, we'll go ahead and check everybody's answers, make sure we got it all right. Then we're gonna go back to our regular spots, and then we'll be working on number 3 on our own. Okay? I'm gonna leave this up here on the board in case you got any questions. Winner, you go ahead and do the same thing. You can work on number 2, and then go ahead and do number 3, and we're gonna come back and take a look at the answers.
She's got.
All right, y'all, here we go. Let's go ahead and take a look at the answers to problem 2 and 3. So again, it's going to be a little bit different than the way we did problem 1. So in problem 2, letter A, instead of measuring like we did in number 1, they already got the measurements there for us. Letter A just tells us to draw a net. So I went ahead and started with my lateral face right here, this rectangle, which they gave me a height of 9, right? Okay? And then they told us that the radius of each base was 2 inches. Okay, so my first step is to find the area of one of those bases. So the area is equal to pi r squared. So I'm leaving pi alone, so I put pi. The radius is 2, so I did 2 squared. 2 squared means you're just doing 2 times 2. So that's going to be 4. Pi times 4 is better written as 4 pi. That's one base. Everybody with me?
Yep.
Okay. So to find the area of 2 bases, we take the answer for one base and just multiply it times 2 because they're identical. So 2 times 4 pi is 8 pi. And that's the answer for both of my bases. So I went ahead and boxed that off so I can find it real easy. Now I need to find the area of my lateral surface. Area of the lateral surface is equal to the area is equal to length times width because this is a rectangle. But I don't have the length yet, so I went ahead and did my circumference. The circumference is equal to pi times the diameter. But 2 is not my diameter. What's my diameter?
4.
4 is 2 of the radiuses, right? So I went ahead and did pi times diameter. That would be 4 pi. So I came back up here to the formula, and in my length, I put 4 pi. My width is obviously 9. So 4 pi times 9 is 36 pi. Okay? Then I went ahead to find the surface area. I just added those two together. 8 pi plus 36 pi is 44 pi. And that is my exact answer right here, 44 pi. And that's part B. That is the answer that they wanted in part B. Part C, it said, now find the approximate. Use 3.14 instead of pi. So I took the answer, 44 pi, got rid of the pi and put 3.14, multiplied it with my calculator, and got 138.16 inches squared.
I got that.
Questions?
No.
Okay, so that one was pretty easy.
It's gonna be on our test.
Yeah, we got stuff like this on the test.
Most of the tests are just a small.
It's gonna be part. I mean, we got like 5 different shapes we're gonna be finding the areas of the surface areas of. So it's gonna be like 1/5 of the test. All right. So now number 3, it's the exact same stuff. They give us a cylinder, but how is that cylinder different? How is the information that they give us in number 3 different than number 1 and number 2? Not that it's smaller, but it's got a diameter, right? So it has a diameter instead of a radius. Okay, and you got that's what got everybody on the last test with circles. They were doing radiuses when they should have been doing diameters. They were doing diameters when they should have been doing radiuses. So that's why I try to redo the test so that you know how to do this stuff. Okay, so we can't make those same mistakes. So I went ahead and drew my net, drew me a rectangle. I don't really care how big the rectangle is. I looked at it and I was like, it looks like it's pretty short. So I would think that would be a long little short rectangle. That's why I drew it like this. Put my 2 bases. Put my numbers, 3.12 centimeters, 10 centimeters for the diameter. To find the area of one of the bases, this area is equal to pi r squared. And this would get people mixed up, is that they're just going to throw a 10 right here and say it's 100 pi. Right? Can't do that. All right, we got to say, oh, this is an R. I need my radius. This is the diameter. So if this is a diameter of 10, The radius is half that, so it's 5. 5 squared is 5 times 5. So that's 25 times pi. Okay? That's one base. To do both bases, we multiply that times 2. 2 times 25 pi, 50 pi. Okay? And then that's one component of my surface area. Then the next thing I said, you know what, I'm not going to keep going back and forth to the problem. So I know I got to find the circumference. So I'm going to go ahead and find the circumference next. So I did my circumference is equal to pi times the diameter. Well, they already got the diameter for me. It's 10. So pi times 10 is 10 pi. Okay? So then I came down here and I said, all right, if the length of this rectangle is 10 pi, now I can go ahead and find the area of this thing. Length times width, 10 pi times 3.2. 3.2 times 10 is 32. So 32 pi.
So you gotta split it? No.
Split what?
When it be like that, no, like, so every time you gotta split it?
Explain to me what you mean split.
No, if you say diameter first, right? Like half it, but over 2. I mean, divided by 2.
Divide. I didn't divide anything by 2 though. I didn't divide anything by 2.
You half, like divided by half. I mean half it.
I never halved it.
How you get 5?
Because 5, oh, you're talking about that? That's what the part you're talking about? Yeah, okay, let me explain it to you then. So, here's a circle, right? This right here is 10 because it's the diameter, right? In this problem right here, does it say pi d squared? It says pi r squared, right? So d would be the diameter. R is the radius. The radius is half of the diameter. So that's how I got 5. It all depends on what they're asking for. If they're asking for radius, like they are in the area problem, I need to use a 5. But if I needed to find the diameter, like they asked me for in the circumference problem, I gotta use 10. Make sense? Okay? Or in the other problem, they gave me the radius, but when I needed the diameter down here, I had to do 4.4 instead of 2.2. So there I had to multiply it times 2 or add it to each other, whichever. So it all depends on what they're asking for, radius or diameter. Good question. All right, so the base of both of my the area of both of my bases is 50 pi. The area of my lateral surface, that rectangle, is 32 pi. So to find my exact area of the exact surface area, I do 50 pi plus 32 pi, and that gives me 82 pi. That's the answer for B. And then to approximate it, that means instead of putting a pi, so I'm taking 82 pi, but instead of pi, I'm going to go ahead and put 3.14. So that's 82 times 3.14, which is 257.48.
What's the majority of our tests that we do?
Everything that we cover. Test is going to be rectangular prisms, surface area, triangular prisms, surface area, cylinders, surface area, hexagonal prisms, surface area. It's going to be doing pyramids next week, so it's going to be different types of pyramids. We'll have just regular old square pyramids. We're going to have hexagonal pyramids. Absolutely, we got a test next week. It'll be like Wednesday, I think, if I remember the calendar right. So like Monday, if I remember correctly, if the test is on Wednesday, we got 2 lessons worth of pyramids coming up, Monday and Tuesday.
Why
And then the test Wednesday.
it had a day called Pi.
Because Pi Day is coming up next Thursday. Because what is pi equal to? 3.14. What's the date next Thursday? 3/14. It's pi. 3.314. Huh? Yeah, that's why it's called Pi Day. And I make the calendar so you know doggone well a math teacher gonna put that it's Pi Day on 3/14.
Exactly, because it will be you. It's always you.
All right. So if anybody has any other questions or you need some more practice, you got 4, 5, and 6 you can work on. If you think you're good, you got both of these right, or you understand what you did wrong, you don't want to make that mistake again. If you got something wrong, I would say go ahead and try number 4, just to make sure that you didn't work out all the kinks. But if you got both of these right, and you're ready to knock out the exit ticket, you can go ahead and take a look at the exit ticket. But for the other class, I want everybody to do the exit ticket. If you don't finish it in class and turn it in, you can do it for homework. So I got Demaya and Christian gave me theirs before the other class. Everybody else said they were gonna do it for homework and have it ready for Monday. Exit ticket is what I want to see Monday. All right, Winnie, you can go ahead and just keep on practicing. You can do the rest of the problems in the lesson. You can work on the practice problems. And if you need any of the answers, comment on Google Classroom and I'll give you all the answers to that stuff.
Hey, Winter.
Hey, waiter! You find out, son?
Oh.